This is Navin, PGT Chemistry, TS Model School, Ibrahim. Today I want to discuss about oxidation number. Before going to know about oxidation number, let me discuss few definitions. First of all, oxidation reaction. A reaction which involves losing of electrons is called oxidation reaction. For example, zinc loses 2 electrons to form Zn+2. So this reaction involves losing of electrons, so it is a oxidation reaction. And reduction reaction. A reaction which involves gaining of electrons is called reduction reaction. Example, copper plus 2, it gains 2 electrons and it converted to copper. So a reaction which involves losing of electrons is called oxidation reaction, and a reaction which involves gaining of electrons is called reduction reaction. And few more reactions are there that involves both oxidation reaction and reduction reaction. Those type of reactions are called redox reactions. In the name only there, redox, reduction, oxidation. And these type of reactions are also called oxidation reduction reactions. So a reaction which involves both oxidation and reduction reactions are called redox reactions. For example, zinc, say copper plus 2 gives rise to zinc plus 2 plus copper. Here zinc is converted to zinc plus 2 oxidation reaction, and copper plus 2 is converted to copper reduction reaction. So this is oxidation reaction, and this one is reduction reaction. So a reaction which involves both oxidation and reduction reactions are called redox reactions. Reduction, oxidation. So when we combine these two, we will get a redox reaction, and it is also called oxidation reduction reactions. So here the number of in reduction reaction, remember, number of electrons lost in a oxidation reaction is equals to the number of electrons gained in the reduction reaction. So the number is same, number of electrons transferred is same. And reducing agent nothing but an atom or ion or molecule. A atom or ion or molecule which loses electrons is called reducing agent. In a redox reaction, the atom or ion or molecule which loses electrons is called reducing agent, and which gains electron is called oxidizing agent. So here zinc loses 2 electrons, so it is reducing agent, and copper gains electron, so it is a oxidizing agent. And remember one more point, zinc loses 2 electrons, so it is a reducing agent, and it is itself will be oxidized. Nothing but it undergoes oxidation. Even though it is a reducing agent, it undergoes oxidation. And here copper plus 2 gains electron, so it is what? It is oxidizing agent, and it is itself will be reduced. So it is itself will be oxidized, and it is itself will be reduced. It undergoes oxidation, it undergoes reduction. So a atom or ion or molecule which undergoes oxidation is called reducing agent. A atom or ion or molecule which undergoes reduction is called oxidizing agent. So this is a reducing agent, and this is oxidizing agent. Reducing agent undergoes oxidation, oxidizing agent undergoes reduction. A atom or ion or molecule which loses electron is called reducing agent. A atom or ion or molecule which gains electron is called oxidizing agent. So we have to know these definitions: oxidation reaction, reduction reaction, redox reaction, reducing agent, and oxidizing agent. Now rules to calculate oxidation number. So see the definition of oxidation number. The number of charges in the atom can have when the electrons in each bond shifted to more electronegative atom. So this is the possible charge on the atom. So the possible charge on the atom when the bonded electrons or the electrons in each bond shifted to For example, when we take HCl molecule, see HCl, chlorine is more electronegative and hydrogen is less electronegative. So when the electrons are shifted towards chlorine, hydrogen gets positive charge and chlorine gets negative charge. So when the electrons are shifted, there is some charge is present on the atom. That charge is called what? Oxidation number. For example, NaCl. NaCl, already we know Na plus Cl minus. Sodium is less electronegative, chlorine is more electronegative. So the charge plus 1 is the oxidation state of sodium and minus 1 is the oxidation state of chlorine in NaCl. Okay, now the number of charges on the atom, the possible charge on the atom when the bonded electrons are shifted towards more electronegative atom is called what? Oxidation number. And it is difficult to calculate the oxidation number like this, shifted by shifting the electron. So there are some rules to calculate the oxidation state. Few rules are there. Let me discuss about that rules. Okay, rules. For ionic compound, how to calculate the oxidation number? For ionic compounds, the charge present on the ion is called its oxidation number. And for covalent compound, the possible charge, say the possible charge on the atom when we shifted all bonded electrons towards more electronegative atom is called its oxidation number. For example, for ionic compounds NaCl, Na plus Cl minus. So the charge present on the atom or the charge present on the ion is called its oxidation number. So plus 1 is the oxidation state of sodium, minus 1 is the oxidation state of chlorine in NaCl. And in the same way, when we take a covalent compound, for example H2O. H2O is a covalent compound. Now H2O shape is like this. Now we are shifting, oxygen is more electronegative atom. So oxygen gets minus 1, minus 2 charge. Hydrogen loses plus 1, here also plus 1, like that. We are shifting the bonded electron towards more electronegative atoms. So it gets minus 2 charge and it gets plus 1 charge. So plus 1 is the oxidation state of hydrogen in H2O and minus 2 is the oxidation state of oxygen in H2O. So for ionic compounds, the possible charge on the ion is called oxidation state and for covalent compound, after shifting the bonded electron towards more electronegative atom, each atom gets 1 charge. That charge is called its oxidation state. And remember one more point, for free atoms in a reaction, for free atoms and for homoatomic molecules, the oxidation number is 0. The oxidation number is 0. For example, zinc is a free atom, so the oxidation state is 0. And copper oxidation state is 0. Silver oxidation state is 0, like that. And for homoatomic molecule, for example Cl2, homoatomic molecules, the molecule which made with same atom is called homoatomic molecule. So here only one, here chlorine is there, so Cl2, the oxidation state of Cl2 is 0. Cl2, F2 and N2, the oxidation state is 0. P4, this is also homoatomic molecule, and Si, like this. For free atoms and for homoatomic molecules, the oxidation state is 0. Now, for first A group elements, remember first A group elements always shows plus 1 oxidation state, and second A group elements always shows plus 2 oxidation state, and 7th A or 17th group elements always shows minus 1 oxidation state. So plus first A group elements always shows plus 1 oxidation state, second A group elements always shows plus 2 oxidation state, 17th group elements always shows minus 1 oxidation state. And hydrogen always shows plus 1 oxidation state, and some exceptions are there. Those exceptions in metal hydrides, in metal hydrides. Metal hydrides nothing but what? When the hydrogen is attached with a metal, in that case hydrogen shows -1 oxidation state. Hydrogen always +1 oxidation state, but in metal hydrides hydrogen shows -1 oxidation state. For example, sodium hydride. Sodium is a metal. In that case sodium +1 oxidation state. In that case hydrogen is -1 oxidation state. And calcium hydride, same. Calcium hydride. So when the hydrogen is attached with a metal, those compounds are called metal hydrides, and in the case of metal hydrides hydrogen shows -1 oxidation state. Remaining all cases hydrogen shows +1 oxidation state. And oxygen. Oxygen always shows -2 oxidation state. Some exceptions are there. In the case of peroxides, superoxides, and oxygen fluorides, O2F2 and OF2. These are the 4 exceptions. In peroxide, oxygen shows -1 oxidation state, and in superoxide it shows -1/2 oxidation state. Actually it shows always -2, but in the case of peroxides it shows -1 oxidation state. In the case of superoxides it shows -1/2 oxidation state. And in OF2 and O2F, in OF2 it shows +2 oxidation state, and in O2F2 it shows +1 oxidation state. These are the 4 exceptions for oxygen. Oxygen shows always +2 oxidation state, but in the case of peroxides it shows -1 oxidation state, and in the case of superoxides it shows -1/2 oxidation state, and in the case of OF2 it shows +2 oxidation state, and in the case of O2F2 it shows +1 oxidation state. So see the rules. First A group element shows +1 oxidation state, nothing but lithium, sodium, potassium, rubidium, cesium. So these are the first A group elements. They shows +1 oxidation state. And second A, beryllium, magnesium, calcium, strontium, barium, like this. These are the second A group elements. They always shows +2 oxidation state. And 17th group elements, fluorine, chlorine, bromine, iodine. These are the 7th A group or 17th group elements. They shows -1 oxidation state. -1. They are always having -1 charge. These are +2 oxidation state, and these are +1 oxidation state. So these are fixed values. And hydrogen always +1. In metal hydrides it shows -1. Oxygen always -2, but in peroxides -1, superoxides -1/2, in OF2 +2, and in O2F2 +1. And remember one more point, the metals in interstitial compounds, and the metals in carbonyl compounds, and the metals in nitrosyl compounds. The oxidation state of metal in these compounds is 0. Remember, the oxidation state of metals in interstitial compounds, in carbonyl compounds, and in nitrosyl compounds. And remember one more point, the sum of all oxidation numbers in a neutral molecule is equals to 0. The sum of all oxidation numbers in a neutral molecule is equals to 0. So when we sum the all oxidation state in a neutral molecule, the sum is 0. In ion, the sum of all oxidation numbers in ion is equals to the charge present on the ion. The sum of all oxidation numbers in ion is equals to its charge, present on the ion. And for neutral molecule it is equals to 0. So by using these rules we can easily calculate the oxidation number of any atom in a molecule. Let me discuss how. First of all, let me take king of chemicals H2SO4. Now we have to know the oxidation state of sulfur. Already we know what it is, a neutral molecule. So the sum is what? The sum of all oxidation numbers is equals to 0. So depends upon that rule, we can easily calculate the oxidation state of sulfur in H2SO4. Now we can calculate the oxidation state of sulfur. Already we know the oxidation state of hydrogen. What is the oxidation state of hydrogen? +1. Oxygen -2. Now see, how many hydrogens are there? 2 hydrogens. Each hydrogen, how much? 2 hydrogens are there. Let me write like this. We don't know the oxidation state of sulfur. Okay, na? So let me take X plus. How many oxygens are there? 4 oxygens. Total how much? 0. The sum of all oxidation numbers is equals to 0. 2 into hydrogen oxidation state how much? +1 plus X plus 4 into oxygen oxidation number how much? -2. Total 0. 2 into +1 plus 2 plus X plus into minus 4 2s are 8 equals to 0. Then X minus 6 equals to 0. Then X equals to +6. This is the oxidation state of sulfur +6. One more example, KMnO4, potassium permanganate. I want the oxidation state of manganese. Potassium is first group element. First group elements always shows what? +1 oxidation state. Oxygen always shows what? -2 oxidation state, oxidation number. So here, how many potassiums are there? 1 potassium. So 1 into K plus, we don't know the oxidation state of manganese. So let me take X plus, how many oxygens are there? 4. Total how much? 0. Then K, potassium oxidation state +1. Why? Because first A group elements always shows +1 oxidation state. We don't know the oxidation state of manganese, X. Then 4 into oxygen -2, total 0. Then +1 X -8 is equals to 0. X -7 is equals to 0. X equals to +7. So +7 is the oxidation state of manganese. Now take one ion, CrO4 -2. CrO4 -2. Now I want the oxidation number of chromium. So I don't know, I am taking 1. 1 chromium is there. So 1 plus, how many oxygens are there? 4 oxygens. Total how much? Now it is an ion. Neutral molecule we are taking 0, but it is an ion. So the sum is equals to the charge present on the ion. So the charge is -2. Now X plus 4 into oxygen how much? -2 equals to -2. Then X -8 equals to -2. X equals to 8 -2. Then X equals to +6. So +6 is the oxidation state of chromium in CrO4 -2. Now take K2Cr2O7. K2Cr2O7. I want the oxidation state of chromium. So here potassium is a first group element. 2 potassiums are there. Now see, 2 chromiums are there. So I am taking 2 into X plus 7 oxygens. Total it is a neutral molecule, so it is 0. So 2 into potassium +1 plus 2X plus 7 into -2 oxygen equals to 0. Plus 2 plus 2X minus 14 equals to 0. Then 2X minus 12 is equals to 0. 2X equals to 12. X equals to 12 by 2. 2 1s are 2 6s are. Then X equals to +6. Like this, by using the rules, we can easily calculate the oxidation state. Thank you.